Welcome to this free presentation of the Oscar 3 installation for Washington State. Our outline for today will cover what an Oscar 3 system is, how it's installed, the startup procedures, and then the certification process for becoming a certified installer. The Oscar 2 is a real simple system. You'll see here it's made up of three main components: septic tank, a pump chamber, and an Oscar disposal component. The Oscar is simply as a on-site sand coil area recharge. It's an acronym that describes what it is. As you can see here, we've got a series of coils laid out on a bed of sand connected to a manifold, a supply and a flush manifold, and then this will be covered with another layer of C33 sand. Now, this is a proprietary technology that does two things. It is a treatment unit as well as a final disposal component. There's actually four components to the system. Really, we've got the coils. We actually have two versions of the coils: a 25 gallon a day version and a 50 gallon a day version. C33 sand is the treatment media. We need 12 inches underneath the coil. There's a reverse flush headworks that controls the flow of water and cleaning and scouring the tubing and back flushing the disc filter. And then we have the tanks, the 1,500 gallon septic tank and a 1,000-gallon pump chamber. The cross-sectional view of an Oscar: in a flat site, you'll see we have a prepared basal area, or the ground surface is prepared. We'll have a minimum of a 12-inch layer of sand under the coils. Outside the coil area, we'll need to have a 6-inch deep sand bed or sand layer. Again, 12 inches under the coils. Coils must be level, and we'll have an additional 6 inches of sand on top of the coils. When the system is completely installed and after we've had a little time for vegetation to grow, you'll see that we have a very lush green grass growth on top of the Oscar, and it's really actually very difficult to tell where it is if it's installed and managed properly. Now, there are 6 steps to the Oscar installation, and we'll go through all 6 of those now. First, we want to do is stake out the basal area. We are going to take the design, compare that to the site, stake it out, and what we really want to do is, if we're on any kind of slope, we want to make sure that the top edge or the upper edge of the Oscar is on contour. If it's a fairly straight contour, only 2 stakes, one at each quarter, will be needed. If it has any kind of a bend to the contour, we may use 3 or 4 stakes to identify that curve shape. Once we've identified the outline of the Oscar, we want to remove or remove the organic material. In 2 different circumstances, we may be in a lawn or pasture area. We don't want to remove the sod, but we do want to cut down all the little tall weeds or grass, remove those clippings, and then we'll do the next step is the basal prep. If we're in a forested area, we have a lot of leaf duff or leaf mat on the forest floor. We'll probably want to remove that material off till we just barely start getting down to the mineral soil. Then at that point, we'll do the basal prep. What we're doing is trying to create a situation where we have broken the surface of the soil up, but we don't want to churn it all up. In other words, we don't need to go very deep. Here you see we're just going 2, maybe 3 inches deep. It doesn't matter what bucket you have, the size teeth, how many teeth per foot. We just want to do this one, I call it raking or basal prep plowing, for lack of a better term, and create these little rows or furrows. Oh, I guess all I should say is we're going to have some material that's going to build up on the back side here. Of course, that will be cast off. Whatever sod or organic material stays in the soil, go ahead and leave that. That's not going to be a problem. Whatever comes up, let it come up. That won't be a problem either. In some situations, we may excavate down a little further if we've got enough soil and then do the basal prep. Here you see that the soil is quite dry. This is in the middle of the summertime, and this soil doesn't have very much moisture at all. And it really doesn't look like we're doing much to prepare the soil surface. But if you'll see, even with that all the fragments, you'll notice we actually do create somewhat of a hummock or a hump, and we want this to go along contour. And what this does is, with the downward movement of water through the sand from the coils and into the soil, once we hit the soil surface, we don't want to create an easy path for water to flow along the surface down slope. So by creating these little humps, we prevent water from, well, we slow it down so it has a more opportunity to be absorbed into the soil. Once we have the basal area prepped, we're going to apply sand. Lots of different methods of getting the sand onto the basal prepped area. You can back up your dump truck right to the edge of the basal area, dump it on. Some people will dip out of the back of the truck. Some people may stockpile and then move it over with a little excavator or loader. In any event, once the sand is on this basal area, you can go ahead and drive small tracked equipment on there to move the sand around. Again, we're just looking with the Oscar 3, we're looking for 12 inches depth of media depth minimum underneath the coil area. Once we have that sand laid out and smoothed over, we're going to connect the tubing. In the kit that comes with the Oscar, or the parts that come with the Oscar 2 kit, we will have these coils. You'll need to assemble them in the field, but they'll be marked what to do, cut at the right lengths. We'll have couplings as well as blank tubing to do the connections. And these PVC fittings at this point here are already pre-done for you. So all you have to do is just cut the pipe and glue into at the appropriate places. And then sometimes on a site where you may have the Oscar may be following a contour and be curved, it may be easier to put both of the supply and flush manifold on one side of the row of coils as opposed to one on one side, one on the other. This has a much more gentle arc or bend to it than it would be on the inside. If you do put both manifolds on the same side, you will need to take note. You want to keep them separated by a few inches. What you don't want to have is the barbed connecting fittings resting on a pipe that would potentially break if it were to get some pressure on it. Now, the cover material that's required is just C33 sand. You don't need to put any topsoil on there to get things to grow. We're going to be subsurface irrigating this with treated effluent, so it will grow quite rapidly. You may, if you want to, put some cover soil on there. If you do, just a few inches, 2-3 inches or so, but have a very low organic mix in that soil. You may want to cover with the sand with some straw. We do recommend getting some grass seed or even sod planted down as soon as possible. Or if somebody wanted to use a ground cover such as Vinca minor or periwinkle, that would be ideal as well. What we don't want to do is to use the manufactured topsoil mixes that are really high in organic and compost material. That's going to hold water and make it appear that the system is not functioning well, when in fact it's just the fact that the topsoil is holding lots of moisture. So once we've put the final cover sand over the top of the coils, the unit's going to look pretty stark. Again, we probably want to put some straw or something down over here. Depending on the site, again, we may want to get some grass seed planted on that right away. If this is at the end of the fall or into the winter season, not a whole lot's going to grow. Placing the seed down will be there when the spring comes. It'll start to germinate at that point. If this is an installation that's done in the spring and it's going to go into operation almost immediately, getting some grass seed down there within a short period of time, it'll grow quite rapidly. And at the end of the presentation, we'll show some examples of that. It takes about 2 hours to put in an Oscar for a single family residence. That's assuming that we can get sand relatively close to the site. But it's a very quick installation to have the disposal component completed. Now the septic tank really only has, I got listed here 3, but it's 2 criteria. We do need to have the tank on the Washington State Department of Health's registered wastewater containment vessel list, and it needs to be a minimum of 1,500 gallons, and it can be either a single or double compartment tank. You could put an outlet filter baffle in if you so chose, but one is not required. Either way, it doesn't matter to us what either way. In the discharge tank, where we're setting the floats up for the pump, at a minimum, we want to have the bottom float such that it'll completely submerge the pump at all times. A minimum of 4 inches separation between the timer enable float and the high level alarm. Local code may require you to have a larger separation here. You're going to need to refer to the design or designer to make sure that you're getting the proper float settings there. The floats come with float clips already. We recommend that the float tree be uh, cut long enough where it actually rests on the bottom of the tank. When you got the floats where you want them, just secure them to the float tree. And we also provide we call it a float bracket, but it's basically an orifice shield with a screw in it. You just screw it to the side of the riser below where the top of the handle would be. Once you've attached the float tree still rests on the bottom, and here you just snap the float tree in place. The float tree does not carry the weight of the float in the float tree, but it just holds it in the upright position. The placement of the reverse flush headworks will go directly on top of the pump chamber. It will be plumbed in as so. We do want to point the two coil from coil lines as directly as we can to the Oscars. We'll come out of our pump chamber at 90-degree angles to the headworks, and we will have a flush line, or what we call a vent line, which will go to a 4x1T supplied within the Oscar kit. Inside the headworks, the internal portion is complete. You will have to glue at four positions: the from coil, two tank, and two coil, and the last one will be from pump. Once those are glued in, the plumbing to the headworks is done. You may want to adjust the box so that the guts to the headworks is centered within the box, so that these valves, none of the valves or anything you need to service, um, will be touching the side of the box. The external portion of the unit will just have these labels that'll tell you where the plumbing's to go. Again, to and from coil are going to be connected to the manifolds of the Oscar, and two tank will go back to that 4x2T illustrated earlier. On the flip side of the box, you'll just see a from pump, and that's going to be the pump line coming from the pump chamber. Most of your installations are going to require a deeper barrier depth than the 1 foot that's 1 foot tall that the riser box will allow. In that case, we always provide a riser extension. The bottom of the box will be removed. The extension will just be placed on top of the headworks box. There'll be about 8 to 10 self-tapping stainless screws. You'll just screw the flange to the extension onto the lip of the headworks box, and that will be firm enough for backfill. Place the lid on and backfill, and you'll be done. The headworks boxes and the extensions work such that if you have a full 2 foot riser on your tank, by putting the riser full extension riser on your headworks box and the lid, you'll come out at about 25.5 to 26-inch tall headworks arrangement. And if you were to compare that with the riser with your lid on there, the lids will be completely even, so it makes it real easy for backfill. Sometimes you'll want to have a riser extension less than a full foot. For instance, if you have an 18-inch tall riser on your tanks, you may want to then measure down from the top of the riser extension down your 6 inches, make a horizontal cut, and then remove the corner on all four corners. Also remove the flange on the bottom, and then screw with the screws that are provided, two or three on each side, just to hold it in place. The extension riser will not settle down with any kind of weight on top. The corners line up so that any of the weight that you may have on top of this extension will be just transferred down through the corner, then down to the bottom of the tank or bottom of the box. And when you're through, it's a little clean installation. And at the end, just put your original lid on the riser extension and backfill. Our control panel, we have a specific control panel that allows us to use this um, in a lot of different applications. We will not be using with the Oscar 3 the pressure switch or the blower. Now, once the system is installed, want to go through the startup procedures, which are really just a quality control check. And what we're going to do is see that we have all the float, pump, and valves wired correctly, and that we got the proper flows and pressures to verify that the system is going to operate as intended. Now, first thing, you kind of want to talk about the headworks just a little bit. In the standard single family resident Oscar 3 kit, we will have a 3/4 inch disc filter in the headworks. It's 120 mesh or 130 micron size opening. It will have 5 normally closed solenoid valves and 3 pressure gauges. Now, the solenoid valves are actually irrigation, or excuse me, not irrigation valves, they're sewage valves. They're all normally closed, which means in order for water to flow through the valve, we have to have electricity to the solenoid to activate it, and we also have to have the pump running to have hydraulic pressure so that water will go through the valve. If you don't have either one of these, nothing will pass through the valve. The valve will stay shut. Our basic reverse flush headworks is arranged as so. We have labeled the solenoid valves with S signifying solenoid, solenoids 1 through 5. We also have 3 pressure gauges, 1, 2, and 3. Gauge 1 measures the pressure on the inlet side of the disc filter. Gauge 2 represents the pressure on the downflow side of the disc filter. And gauge 3 measures the pressure after the coils in the Oscar 3 drain field. The control sequence is such where we're going to have 90 doses repeated over and over again. Once we get to the 91st dose, we're going to back flush the disc filter for a quick 15-second blast, a short rest, and then we're going to do a coil flush where we forward flush the coils for 2 minutes, and then we go back to doing 90 more doses. Now, with the Oscar 3, depending upon whether there's water available, this may happen 1, 2, up to as many as 4 times a day. We may repeat this process. If we're operating at 100% design flow, it will happen 4 times. Typically, with about 50% design flow on average, we're going to see about 2 of these flush cycles happening per day. So if we want to check out and manipulate the headworks to verify whether the wiring is done correctly, we have to do 2 things. We have to again energize the appropriate valves so that they open up, and we're going to also have to turn the pump on. We have 4 toggle switches in our headworks, or excuse me, in our control panel. One toggle switch operates the pump. One toggle switch operates valves 1 and 2. One toggle switch operates valves 3 and 4, and then the last switch is for valve 5. So to mimic a dose, we're going to turn the pump on and energize valves 1 and 2. And so the flow path will be the green line, and the valves that will be turned on again are valves 1 and 2. And this will allow the Oscar coils to be dosed. Because valves 3, 4, and 5 are closed, the only flow of liquid through the system will be to and throughout the emitters in the coils of the Oscar. And this is what the flow path would look like. Now, once we've done our 90 doses, we're going to want to back flush the disc filter. The normal flow through the disc filter is, as you see here, the water flows on the outside of the discs to the inside, and then flows from the center, after it's been filtered, out to the coils. What we're going to do is we're going to reverse this flow. So we're going to pressurize the internal portion of the disc cartridge, forcing the discs to separate slightly, and then having a high velocity, high pressure flow of water, removing debris that's within inside the discs themselves. To do that, we need pump hydraulic pressure. So pump one will turn on. We'll turn valves 1 and 2 off, and we'll turn on valves 3 and 4. Now the yellow line will be represent the flow path. Here, valves 3 and 4 will open. This will cause the liquid flow to go backwards through the disc filter and then back to the tank. And this is what that flow path will look like. At this point, virtually all of the pump's capability, 28 to 30 gallons a minute, is going to be forced through that small disc filter. So we get a tremendous amount of cleaning every time we do this back flush sequence. Once the disc filter has been flushed, we're going to now mimic what the coil flush would look like. In this case, again, we're going to need to have pump 1 on. We're going to turn off valves 3 and 4. And we're going to turn on valves 1 and 2. And because we want to flush the coils, we're going to have to turn valve 5 on. So it's going to be very similar to a dose, except that with valve 5 being open, we're going to relieve all that excess pressure and flow so that we scour the tubing. And again, this will be the flow path that was represented by the green and red lines. Now, when we measure the flow, we use these NetFM meters, and they're set up just a little bit different than your normal flow meters. Go through how we read these. We're going to have an odometer reading on the top, and we have 3 red needle dials along the bottom. On the right, you'll see the dial on the right is each digit is 1 gallon, so each rotation will be 10 gallons. In the dial in the middle, the red dial in the middle, is each digit is a tenth of a gallon, so one rotation's 1 gallon. And on the far left, it's 1/100th of a gallon, so one full rotation is a tenth of a gallon. So if we were to read this flow meter, this first black background 2 actually represents 200. The second 2 is 20. And the painted 0 on the face is a placeholder for the reading on the right dial. So if we were to read this dial and record what the flow says, we would say it was 220.64 gallons. It's one thing to note that we have 2 different coils. The OS50 and the OS100 coils have a flow rate, once they're completely pressurized, of 0.35 for the OS50 coils. The OS100 coils are at 0.7 gallons a minute. The question then becomes, well, what do we record? Here we're going to record basically pressure and flow. When we're dosing, we're only really concerned about what the pressures are during the dosing sequence, as well as the flow rate. And again, we measure this once the pressure has been stabilized on all 3 of the gauges. Now, a little bit about the certification process. The first step, which you're doing now, is the classroom or online training. Once you're through with this training, what you'll want to do is to give me a call. And what we'll do is we'll place your name on our certified professional list. That'll be posted on our website. Then once you do your first install, we'll have a representative come out and walk you through the 4 main components. Actually, there's 2 main components for the installation. Our time on the field really is probably less than half an hour. When we get there, we're going to expect that the tanks are already installed in the ground, and if you're comfortable, the first sand layer is already down with the Oscars. We'll be showing you how to plumb the Oscars correctly, placement of the headworks, setting the floats, and that's really pretty simple process. Once then the electrical is done, we'll come back and do the startup procedure, make sure that all that's working correctly, and then any additional training as needed. We're always available for phone calls, emails. If we need to come back out and do some other training in the field, we're more than happy to do that. And of course, you're more than welcome to rewatch this video any number of times, anytime you'd like. We want to thank you for your time and interest in the our Oscar 3 product. Thank you.